meeting for this month. We missed last month's meeting, or last meeting 2 weeks ago. That was during the solar eclipse, and there were a lot of people out of town. So I decided, and the board decided to just forget last week's meeting. So I want to thank everybody for joining. Introduction wise, I want to introduce those board members that are on here, so people can recognize who they are, and then we'll continue on with personnel membership introductions. So Paul, you're up there first on my screen. Then Rick Habley, our newest board member. He lives in Colorado Springs, out in the Black Forest area at 7,500 feet. He lives in the Arctic of Colorado Springs. And Bill Miller, our vice president and current building manager. And next on my list is Don Latham. He's up in Montana. He's been a great member for us. Let me see who else we have here. Floyd. Floyd does not have any video tonight. He lives here in town. Floyd's our secretary. And I'm still waiting on, oh, there's Dan. Nope, I guess not. I don't see Dan yet. So we'll introduce Dan Lane, our other board member.
Yeah, we have to come back to take a look at that refrigerant on.
Oh, okay. So as far as members go, we've had a lot of new members. Who keep on board here that I haven't seen here lately or at all? I'll say good evening to Michelle out in San Diego. Good evening to you, Michelle.
Hello there.
Good to have you on board. The one that says Craig, KF0 OGQ. Good evening to you. I'm sure I've talked to you before, but I apologize for not recognizing your call right away. John Hammock, he just joined us this past week. John, where are you located at?
I'm in Oregon, Southern Oregon, but now I'm currently in Utah, but traveling, but be back in Oregon. Okay, one of our out-of-staters, which we have quite a few of them. We also have Alex, K6VHF, our latest engineer, technical engineer, who does a lot of the work. He's in Chandler, Arizona. And let me see. Don Heiss. Don joined us a couple weeks ago. Where are you at, Don? You're up here locally, aren't you? I believe. He may not be able to turn audio on or listening right now. And Derek Brady, there's another new one that recently joined DSES. Where are you located, Derek?
I'm just north of Watkins, out near Bennett, so not too far.
Okay. Here in Colorado?
Yes.
Okay. And our Chad N0YK out in Scott City, Kansas. He's an avid VHF, UHFer, and has helped us out on 1296 when it comes to listening for the Haswell site occasionally to do signal checks. And I hear his 2-meter beacon about any time during the day here in Colorado Springs. It's about a 210-mile path, and we used to talk quite a bit on 1296 over that path, but I've had antenna issues lately on my end. So Sunday, good evening, everybody. And for those who went to the eclipse last 2 weeks ago, who would like?
Hey, Myron, I'll say a quick hi here.
Hold on.
Yeah, I was couldn't get my my phone on, but yeah, here I am. So I'm in Fort Collins, and I'm glad to join you.
All right, Don, thanks a lot. I believe you met Paul and Bill Thomas at a Hamfest recently.
I did, yes.
Okay.
Yep.
And thanks a lot for joining.
Sure thing.
So who wants to say anything about their experience at the solar eclipse before we get into the agenda here?
I have a cloudy picture.
Sure. This is Jim. Jim, tell us where you went to.
Actually, I think Bill was Bill Miller was the show.
Oh, okay.
Stuff. So he beat me to the image. We were camped near each other, so let him take over, and I'll show you what I shot.
Okay, go ahead, Bill. You're on mute, Bill. Nope, still can't hear you.
Not plugged in. That's
There
the
you go.
problem. All right. Yeah, if you don't have your headphone all the way plugged in, it doesn't work. I'm going to share this video with you real quick. Can you see this?
Not yet.
That's the wrong one. Let's see. Let's get back and do the right thing here. Share this screen and that share. Okay. There you go. All right. Here's Jim taught me how to use my C-Star. I didn't get a chance to use it, a little C-Star telescope. So Jim taught me how to use it, and this is what we got for the eclipse in Fredericksburg, Texas. If anybody can't see this, let me know. And there's no audio on this particular one. But this is the partial leading up to the totality. It was a time lapse, and so I stretched the totality out here so you could kind of see what it looked like. We had a lot of clouds, and in the second half of the totality, it almost went away altogether. There, it did go away altogether, and then we come out of totality back into the partial. So that's what I captured on the C-Star telescope. Jim, you want to go ahead and show yours?
Okay, I've never tried to share an image, so
There's a, if you have the
I'm
image
on it.
on,
I'm on an iPad, so I'm going to click share image, and then I'm going to switch over to the picture, and let's see if that works.
okay.
Okay, so I'm doing the screen. You should probably see yourself. Clicking start broadcast. Go here.
Oh, there you go.
Are you able to
There we
see
can
that?
see it. Yep.
So this is what I got through the soup. You can see some prominences and a little bit of the magnetic lines, but too many clouds, not really spectacular. The 2017 was much better, but I was glad to be down there with a bunch of friends down in Texas.
Yeah, we had a good time down there. I'm going to share one more here. If you, let's see, I guess you'll have to
Let's see,
release.
let's
Okay, there
see,
you
I'm
go.
going back. I'm clicking stop sharing. You should be good.
All right, I'm going to do one more here. I think this is kind of the excitement part of it. If I can get it to play. See, I'm in this one, say share, and then say go. Maybe. Okay, this one should, I don't know. I don't know if you can hear the audio on this or not.
That's kind of what we saw, Bill. It's interesting. As soon as the temperature dropped, the sky got more cloudy, and the middle of the eclipse was kind of hit and miss. But then right toward the end, it cleared up again.
Yep. All right. Let me, I don't know. Could you hear the audio on that, the excitement?
Nope.
Oh, that's
No.
too bad because everybody's cheering. Yeah, and you're right, Roger. As soon as the temperature dropped, it's like the clouds formed. And so what little clouds we had at the beginning turned real cloudy during the middle of it. So it's kind of interesting.
Yeah, I think that it has to do with the temperature drop that occurs.
Yep.
Could I share a picture really quick that has nothing to do with the eclipse?
You bet.
Is that working? Since
Yes.
my entire screen changed?
Yes, we can see it. Got students.
Okay, so we had a successful ISS contact today. And this is the kids that are lining up to speak with the astronaut.
Okay, so you're on what, a 440 2 meter.
That's 2 meter link.
Nope, just 2 meter.
Just 2 meter.
Yeah.
To the ISS, and the kids are talking on your transceiver to the ISS?
Well, so there's an organization called ARIS, ARISS-USA.org, that has equipment, and they send, if a school, applies to ARIS, and if they, win the application, they send, a full Yaesu elevation azimuth antenna to the school, and a VHF amplifier, and a Yaesu radio, and all and a laptop and everything to be able to do this contact. So it was none of our equipment, but we did have some redundancy. Dave Molta, that you might see back between the two of that's Dana Gardner, who was that's kind of holding the mic there. She was the one that spearheaded this whole thing, and they held it at Stratton Meadows School, but the sponsoring school was actually Thrive Academy, which is a homeschool academy. You can kind of see partially their banner there in the background, but after a 10-second scratchy start, it was clear as a bell. We had a fantastic connection to the astronaut until, of course, it set approximately 10 minutes later.
So you had 10 minutes of contact.
Yeah.
Yeah, they had a good signal. I heard that station on my handheld with a rubber ducky. They were full quieting space shuttle.
Wow.
I listened to the pass before that. Did you guys listen to that pass at all, Roger?
The
previous...
Yeah, we at 10 something, we did listen to it, but it was a very low pass. We didn't hear anything.
Oh, really?
We weren't listening to the. Go ahead.
The pass before that, I listened to it. They were strong. There was a low pass, but I think they were talking to South Carolina station school, and I heard them, and I thought, well, did I miss it because it was an hour earlier, hour and a half earlier? Well, as it turned out, it was the another contact with another school, and when your contact came in, and I listened to it all the way across, and last time I heard the space station as it went over the Caribbean, last I heard it, and it was very, very interesting. You guys did a great job. I listened to the input frequency, and I could hear the students talk up to it, the uplink, and I heard the downlink from the actual space station. So it was a great conversation. You guys did a good job. The only comment I would have is somebody needs to clue in the people up in the space station to don't talk so much. Let the students talk.
Gee, you noticed that as well.
Yeah. I mean, I'm sure a lot of kids did get a chance to answer questions because the explanations the astronaut gave could have been shorter.
Mm-hmm. Yeah, and especially that last answer.
Yeah,
went on and on and on until it's set.
Yeah. You didn't have a chance to close out the conversation, but yeah, overall, you guys did a great job. I listened to both ends of it, and I'm glad you guys finally got everything working and operational. Because there for a while, back in February, January, there was some tough times getting things working.
Yep. Well, about the only problem we had was with the
rotor
controller itself.
Yeah.
And given the width of the signal on that beam antenna, we probably could have run that manually. But I will pass on your congratulations, because the actual QSO, the organization of that had nothing to do with me.
Yeah. Well, you helped out, or you were there in moral support anyway.
Yeah.
Yeah.
No,
So
I was mostly up on. I've been on the roof of that gymnasium more times than I can count now.
yeah, the next pass that came over after you guys finished, it was too far away for any schools to participate, so they had the repeater turned back on. So I did work 2 stations on the space station repeater. One in one in Mexico and one in Arizona.
Oh, okay.
So that was I haven't done that in a while. So okay, that's great. Anybody have any other pictures they want to talk about on the eclipse? Ray, you were down there. Do you have anything you want to talk about on the eclipse? Earth to Ray. Okay, I guess not. Anybody else? Oh, Don Latham, you guys traveled all the way to Ohio for the eclipse.
Yeah, we did. 3 days of driving, 3 minutes of eclipse, 3 days of driving.
Hey,
My son had an old friend that lives in Findlay, Ohio,
yeah,
which was quite close to the center line,
yeah,
and had about 3.5 minutes, almost 4 minutes.
yeah. Well, I mentioned
This was, I've seen about, I don't know, 10 or 11 eclipses. This one was, I think one of the first ones I've seen that's right dead almost in the middle of a maximum.
yeah,
And there were red traces all around the edge.
that's
From
fantastic.
yeah, from which was really very strange because there was one medium-sized sort of sunspot and one very small sunspot, and that's all that was on the face of the sun.
Mm,
Everything else was on the limbs, or actually either coming or going, so to speak. And so the the length of the prominences was short because they're actually behind the limb of the sun. So it was quite a deal. And the sphere was quite donut shaped. Most of the ones that I've seen in the past have had large wisps of like leaves sticking out. This one was very donut shaped, almost uniform, which means that there's lots and lots and lots of sunspots, all active all around the edge. It was very interesting indeed. I don't have any pictures. I gave up
Okay.
along about number 5 or 6.
okay,
You try to take pictures and you lose the eclipse.
yeah.
So
So,
to heck with it.
I mentioned before that Findlay, Ohio is where I was born at and grew up there. And
Yeah.
another one of our members, Fred Brandenberry, him and I both grew up in that area. We were
Be darned.
classmates in high school for many years.
Well, yeah, I took my car right past the Cooper Tire Factory
yeah.
with my Cooper tires on the car.
All right. Before I get to Ray, Martin Flynn, Martin, I want to get to you before it gets too late since you're in New Jersey and it's already pushing 9 o'clock there.
Hey, Byron, I have one photograph from Black Forest, or it's kind
okay.
of a montage.
Let
me show you that just real quick.
Sure.
I was supposed to go to Dripping Springs, Texas, and I got the flu. So I wasn't able to go. I don't know if you can see that or not.
Yep.
Yeah. So I took these pictures in my backyard here in Black Forest. So I think we were supposed to be about 67% covered. And this is kind of a montage of the pictures I took. So you can see the main one bright sunspot here and then another dimmer one over here. I think gives you a feel for what it looked like in Black Forest over
that's pretty good.
3 hours.
Yeah. Yeah, we had fortunate to have some really good weather here when it happened.
Yeah, it was. We looked like thunderstorms forming all around me when I was taking pictures, but it stayed pretty much clear with some very high cirrus and able to get some good shots.
Ray, what do you have to offer?
I don't have anything to offer, really.
Okay.
Had a great meeting with Rick and on Saturday and after the breakfast, and we talked about a lot of things. And I think I'm going to come up with a shocking discovery later, but I'm not ready for it yet.
Okay. But as far as the eclipse go, Ray traveled down there with his 2 youngster kids.
Both in their 60s.
Both in their 60s, and made a side trip over to Arizona to see Alex as well. So
yeah, we got a chance to look at the eclipse just exactly the way Bill and the rest of them did.
Yeah.
Bill and Jim, and so we didn't take any pictures.
Okay. I want to get to Martin Flynn. I sometimes don't get to him and he has to leave, but it's late out there in New Jersey. Martin, do you have anything to add, or tell us what you've been up to lately and how the dish is working out there in your neck of the woods at your site?
Well, we finished expanding the control console and adding a VHF and UHF position to it. The new countertops are being made. For those of you that don't know, it's the same console system we sent out to Haswell on the first load of equipment. The gearbox was taken off by the team from Princeton. It's being overhauled the second time. The elevation drive on our TLM-18 is a recirculating ball antenna, and it was overhauled once, and the vendor who did it appears they didn't do too good of a job, so it's being overhauled again. Let's see what else. The 40 gig fiber feeds are being pulled in from my weekend employer. So that's two. We have to change our edge routers too to larger Cisco 99Ks because the little ones we have won't handle 40 gig of throughput. And we have the interesting problem of trying to find a firewall that'll keep up at 40 gig wire speed. That's basically it. Any questions on anything?
Yeah, Martin, this is Bill. You say you worked on the control console desktops. Do you have drawings for those?
Ours is just a straight line, Bill. It's yeah, I do. If you want them, I'll send you the AutoCAD files.
Yeah, that might be good because then I wouldn't have to replicate them.
Yeah, well, are you doing a straight line, or are you doing the kind of
Well,
sort of
we were
C-shaped
gonna,
one?
yeah, we were thinking about a C-shaped configuration, but I could figure it out from there. I just need to know the dimensions is all. And you just use countertop material?
No, actually, we have a pretty good wood shop on site, so we're making up two pieces of 3/4 inch with staggered joints and biscuits where they join together, and then we're putting laminate and an oak bullnose on it. One of our guys is a much better carpenter than I am, so he's taking care of that.
We'll probably just go with countertop because we don't have that capability.
Well, our original countertop came from our Home Depot. We just bought it, cut the backsplash off, and screwed it down.
That's what I was thinking. Yeah.
We're getting to the point now where we can start to work on the nice to have items versus just staying up and running. So
yeah,
we're gonna go a little upscale with that.
Oh, cool. Okay.
And actually, the laminate and plywood worked out cheaper than buying two other pieces of pre-finish from Home Depot. So it actually was, other than the volunteer labor, was more cost effective.
Martin, for the new people here, the info age, can you brief 25 words or less tell what you got out there?
Oh, that's at least 50 words.
Okay. I'll give you 51.
I'm the CTO for InfoAge. InfoAge is a science technology museum that occupies one half of the former Camp Evans property. The other half is the community college. We have 23 buildings, just about 6.5 acres under cover, according to our PE. We also, as part of the deal, ended up with a 60-foot dish antenna with a horizon to horizon drive. And if you go way back in the history of the space age, this is where the first weather satellite images were downloaded. So being it's Army property and the Army demilitarizes everything, that's just what they did to the dish. And our stubborn volunteers undemilitarized it and put it back into service. We have feeds for 1296 and 440. It's horizon to horizon drive. It'll slew about 6 degrees a second if we push it. We don't like to. It's kind of, since it's a little older than I am. The driving control, the control systems were designed and built by Princeton University. Just about everything else was done by the Ocean Monmouth Amateur Radio Club and our volunteers.
All right, sounds good. A lot of people kind of hear about InfoAge, but don't know much about it. So really appreciate your description there of what you got out there. That's how many is in your organization?
Well, it's if you total everyone up, including the squirrels and rabbits running around the property, probably about 120.
Okay. All right, well, with rabbits, they probably multiply a little quicker. So, okay. All
Well,
right.
the American bald eagles we have on site, consider them very helpful and tasty.
Well, that's good. That's a good predator control there. All right. What we got here? Oh, who posted that? Yeah, that's true.
Yeah, I saw this one. I thought this was great.
Can you hear me now?
Yeah, it's
Yeah.
Roger.
Okay.
I said, yeah,
Yeah,
it's gotta be Roger.
This is a nerd cartoon called XKCD, and since we were doing eclipses, I hear so many people that say, "Yeah, it was a 94% eclipse. It was 94% of what you saw." It's like, no.
Yeah. Okay. That's good. All right. Before we move on to the program for tonight, anybody else have anything to add on the eclipse or what we just talked about with Martin and or the IRISS group? It's amazing how well you could hear the space shuttle today for the space station.
I'll just add, so I was in Kerrville, not far from Fredericksburg, so I saw pretty much the same thing that Bill showed with the clouds and everything. I did see the sunspots that Don talked about, but in the clouds, we had a very annoying experience. A news helicopter from San Antonio kept flying over us. We were in a soccer field, and there was a bunch of people there, so a news helicopter was very, very a big nuisance.
Yeah. When we were in Glendale, Wyoming during the eclipse there was a hot air balloons flying over, and that really ticked off the people blocking the eclipse with the balloon in your way. Of course, in a basket under a balloon, I don't know how you could see the eclipse anyway, but somebody was making money.
Yep.
All right. Well, Dan Lane's one of our other board member. When we were doing introductions, Dan hadn't joined us yet, so we'll be talking more with him later on and other activities here. Glenn, are you ready to go with your presentation?
Yeah, I think so. Are you ready, Louis?
Yep.
Okay, I'll bring up the charts.
Glenn and Lewis and also Phil Gage are our three primary gurus when we wouldn't be where we are today as far as pointing the dish and knowing where it's pointing unless these guys were down there doing a fantastic job of providing all the software and hardware to make sure this thing works. In the early days, we would get out there and look to the horizon and say, I think we're pointing about north. Then we try to talk to somebody terrestrial and they may or may not hear us. Now we're pretty sure we're actually aiming to where, we're pointing to where we're actually aiming the thing. So go ahead.
Okay, so go ahead, Louis. I'll run the slides for you.
Okay. We've been working on upgrading the encoders from 12 bits to 16 bits for quite a long time now, probably over a year. And I think we're actually approaching the end of that activity. Maybe one more trip and maybe we'll be done with that part. So this is what I was going to talk about. Just an overview of the upgrade. The activities we did on this last trip. And then talk about the results that we had from the activities there. And then at the end, just one slide on future work. So next slide. I kind of covered this, but it's been updated a little. Overall, what we've been trying to do is just improve our pointing and tracking with the goal of getting to maybe better than plus or minus 500s. And the current system that everybody's been running probably does between 0.1 and plus or minus 0.1 to 0.15 or maybe even 0.2, which is not bad, but we think we can do better. That system's limited by encoder resolution, tracking accuracy, and then in the CAL, our ability to determine where the actual pointing angle to the object is. And so we identified some things to kind of address all those issues, and that's in the approach. So the first is to replace the current encoders with 16-bit encoders, and that's in progress, but hopefully will be finished here very shortly. The next two had to do with improving the calibration itself. And so worked on improving the scan pattern so that it focused more specifically right on the object, got more measurements in the scan at a finer resolution, and didn't get so many measurements outside of the object. And that's kind of to make the scan more efficient and more effective. And then we replaced the current, or looking at replacing the current algorithm that determines where the object is with a curve fitting approach. The current approach just kind of centroids the object position from all the scan position data. And while it works, I think it's not super consistent, and I think the accuracy is limited to some extent. And so we're replaced it with the curve fitting approach using this so-called Gaussian function. And the reason that that's useful is a parabolic antenna's main beam pattern is really Gaussian shaped in general. Or well, I'll say the main lobe of the rest of the pattern is not Gaussian, but the main lobe is. And then to do this, we do an AS scan followed by an L scan, and then we fit the data on the AS scan and to find the azimuth pointing position to the object, and do the same for the elevation. And we'll show some runs here later. As kind of the final thing we're going to look at is just improved tracking algorithm. One thing I'll note, and I've kind of forgotten about it, it used to be before we had implemented this, tracking was done from the manual front panel, and it turned on, and the operator would flip switches to control the tracking of the mount. And this capability we have now is essentially kind of a computerized version of that, and we just need to make it a little more sophisticated. So.
Hey, Lewis, how do you define tracking accuracy, and do you measure it by the curve fitting method that you talked about?
We probably could get statistics out of the Gaussian fit, but I haven't done that. I'm not a great statistician, but you could get error bars and things out of that. I just have not tried to learn how to do that yet. So I basically we look at the offset error we're getting, and for instance, in this case, we've compared the offset errors from the current system versus this upgraded one. And we'll talk about those values, but if that's a subject you have knowledge in, I'll be welcome to work with you and try to do that. Next slide. You see, this just tells basically how we do our position determination, and the offsets are stored in an initialization file, and these offsets are really the difference between when the mount is pointing at 0, 0, it's the difference between 0, 0 and whatever the S and L axis encoders are reading. And so that's what we call the axis offsets. That's as sophisticated as our mount model is right now. We don't model, like gravitational effects on the antenna. Right now we're not modeling any atmospheric effects, maybe things like that. Those are definitely second order effects below this. We see using initialization values. Let me see. Yeah, Glenn, you might want to talk to this. I'm not as familiar with them.
Okay, so the software uses the initialization file, the DCS properties file, to read in those 0-point offsets. And like Lewis was saying, if you go into the initialization file, you'll see an integer value in there. And if you pointed the telescope at the 0 point for both axes, it should give you back that encoder position. So what we're doing with the mount calibration is we're trying to figure out where that value should be set in the initialization file. Since we're dealing with 16-bit encoders and we're dealing with 360 degrees, we can quite simply, divide 65536, the 16-bit value, by 360, and that gives us 182 counts per degree. So we can take the 0 encoder position, and we can take the encoder position we're getting currently from the mount, and by doing that, we can figure out the azimuth degree position and the elevation degree position by using these initialization values. So the mount calibration, or the encoder calibration that Lewis is really going to talk about, what it does is when it's completed, it goes back and updates those values so we're more accurate. And you'll see in Lewis's data, we ran multiple cows, and you can see that we get more and more accurate as we updated that initialization value, or the 2 initialization values.
Yeah, just as an add to that, the 12-bit encoders, the resolution is about 0.089 degrees. I typically just round it to a 10th. And the 16-bit encoders, the resolution is 5.005 something or another. It's roughly 5,000ths of a degree. So since we have 4 bits more, that basically our resolution is like 16 I won't say 16 times, but the resolution is 16 times better. So next slide. On this last trip, the encoders were already installed in prior trips. We just had this problem, a clearance problem in the elevation axis cover, which Ray and Bill on a trip just a little bit prior to this trip, they fixed the issue, and now we no longer have any really clearance issues or anything like that with either encoder. So the other thing we did when we routed the elevation axis Ethernet cable through the conduit, there were some tight corners and such, and the RJ45 connector got damaged, so we had to replace that connector. And so for this installation, we just had to connect the ASL Ethernet cables to power over Ethernet switch in the pedestal, and then connected the switch into the overall site Ethernet network. One node is still in the installation. The switch, we just had it temporarily on the floor in the upper pedestal area. We need to mount it in the box, and that's what we'll be doing on our next trip. Also, as Ray had pointed out last meeting, we need to provide strain relief, actually not only for the axis, for the elevation axis, but also for the azimuth axis. So we're going to take some cable clamps and ties and such that will allow us to fix that issue. So once we had them installed and connected into the net, we proceeded to just make sure we could read the encoders, and basically Glenn has a software tool that runs on the ops console laptop. And in this case, we had a kind of a duplicate ops console laptop that we could run it on without modifying the existing laptop. And we ran that tool and verified that we could verify that we could read angle data from both ASL encoders, and it looked like reasonable data. So that was just a basic interface check. Then we went to the next step, just on the next slide, where we ran both sets of encoders side by side. We're able to do this because there are multiple shafts on each axis that you can mount encoders on. And so currently we have the 12-bit encoders still mounted on the shafts they were originally on, and we have the 16-bit encoders on another shaft. And we ran two systems simultaneously. We ran the current system with all of its current hardware, including encoders of the Raspberry Pi and the tower, and the ops console in the trailer that's running the current version of the software. We also ran the 16-bit encoders on an enhanced system one, which we had another Raspberry Pi in the trailer. It's attached to the Ethernet, and it was acquiring the angle, passing them to the independent ops console laptop. The ops console laptop was running the enhanced software that has the new calibration scans and such. So we ran that. Initially, what we did is took the ASL 0-point offset values from the 12-bit encoders, and then manually updated the ASL offsets for the 16-bit. So that was a kind of a rough calibration. And then we just wanted to make sure, because we've had issues in the past with encoders running in reverse and such, we just moved the mount in both directions on AS and in both directions on L, and make sure that the mounts or the encoders were giving equivalent readouts. The 16-bit obviously has more resolution, so we just verified they were tracking about a tenth, within a tenth of each other. And that all worked out pretty much straight out of the box. It looked really good. So we went to the next step.
So Louis, can I just say something real quick?
Sure.
So what Louis is describing is how we did the side-by-side stuff. What really made it work well for us is that we could point the telescope essentially at, let's say, 0 azimuth, and both systems were running simultaneously. So we knew we were pointing correctly via the 12-bit encoder because we could see that we were pointing at 0. And then we could look at the 16-bit encoder and we could see the actual value that was reading back. So that value that was being read back, we could go back and put back in the initialization file. And then, like Louis said, we got a rough calibration by doing that. So we essentially used the 12-bit system to point in the right place. We read the values off the 16-bit encoders, put them in the initialization file, and then we could run, we had a very good rough calibration. So I'll go on to the next chart.
Let me ask a question about that before you go on. Now, is the intention to leave both of these systems in place so we have the backup of the 12-bit system with the 16-bit system?
That's something we should probably discuss. Maybe for a while we should run in parallel with both of them. But the real issue is for a non-technical operator, if there gets to be a problem, how does he switch back and forth? And I'm not quite sure how to do that just yet.
Yeah, I was kind of thinking they could be separate console programs,
right,
in the machine driving all this, but it would be nice to have that capability to jump back to the 12 if anything happens to the 16 or vice versa.
So maybe what we could do is we could put icons on the operational laptop, and one brings up the 12-bit and one brings up the 16-bit. We maybe be able to do something like that. That's something I haven't quite figured out how to do yet. And the real issue is really over on the Raspberry Pi more than it is on the operator console. Now we could have two Raspberry Pis installed simultaneously and do what you're saying, or we're going to be able to have to flip back and forth on the Raspberry Pi between the two different sets of software, because the 12-bit encoder is a parallel type interface coming off the Raspberry Pi, and the 16-bit encoder is a TCP/IP network to the actual device. So the interfaces are totally different.
Yeah,
So,
I would say the two Raspberry Pis makes the whole thing redundant.
yeah. So, and I probably have an extra Raspberry Pi, so we'll have to take a look at it.
Okay.
Okay.
So at this point, we thought that we're ready to try calibration. We ran the calibration on the enhanced system 1 since it has the updated software. At the time, I'm not sure it's still this way or not, but the 1296 speed was up and there was a down conversion to 28 megahertz. I think that was left over from some EME things. So we set up the system 1 receiver to receive at 28 megahertz center frequency, 8 megahertz sampling, and 8 megahertz bandwidth, 5-second integration time. Other than the frequency, that's the standard RF parameters that we use when we do the integration or when we do the calibration. We were after getting all the installation and such, we really didn't have a huge amount of time, so we really only ran calibration on one object on this trip. That was Cas A. It's the good thing about Cas A is it's always up. In this case, it was very high elevations, which I think was a good thing. We weren't dealing with low elevation issues at all. So the first thing that we did is we performed a rectangular scan with centroiding to verify, the initial offsets. Good news is Cas A was pretty much in the middle of the scan, so that verified their offsets were reasonable, and we updated the offsets from that scan. So now we have calibrated offsets. Then we performed several cross scans and updates, which we think is our more accurate calibration, but there were no changes being made in the axis offsets. So so Glenn looked around and found an issue with about how the offsets were not being updated and corrected that. And then we ran 3 cross-scan calibrations to find finer offset updates. And we'll talk about the results from that in the following slides.
It was more of an operator error than a software error.
Oh, yeah. So this was the initial rectangular scan. Down below is the pseudo image that we generate out of the scan. And I think the unfilled circle in that diagram is the expected position, and the filled dot is the detected position. And it actually illustrates one of the issues with the centroiding, in that the centroiding didn't always find the brightest center spot because of the irregular shaped object. And so that would tend to skew the results. Not a lot, but some small amount. The offset errors you can see here were like 0.15 and minus 0.2, which that's kind of the range of offset errors that we get, when we run the old scan and centroiding. And to a large extent, the reason we got those was because we were running with a model generated basically from the old calibration is what it amounts to. So, but this after the update, it gave us a starting point to go on to the more finer scans at this point.
Hey, Lewis, this shows about a half a degree on the chart for the width of the object. How wide is this Cas A? Did we know?
Cas A is, I actually have obtained a radio image that's generated by forgot what the sensor was but they show it as 6 arc minutes in diameter.
Okay.
So that I think that's roughly 1/10 of a degree. So it's like it's a supernova ribbon, and it's kind of a hollow circle is what it really is. And so it looks like, given that our antenna has, in this case with 1296, about 0.9 or 0.85 HPBW, it's probably around maybe a little over 10% of the diameter of the half power band. So I think we can in general consider it a point source.
Okay.
And I keep wondering why it's kind of regular, and I think it's because in that small semicircle, it's not an even power distribution in that when you look at that image. It's some spots it's brighter than other spots on there. So I'm not sure that the geometric centroid lines up with an average centroid of the power. So, which I think I've always questioned whether this is the best Cal object or not, but the good thing about it is it's really strong. You don't have any trouble seeing it. But when we go to other objects, we didn't get to do it this time. The calibration seems to hold up, so I don't think it causes a lot of issues. We definitely could not see it with our lower resolution encoders, but we may start to notice things like that now.
Very good. Okay.
Let me see. So we did 3 cross scans, and the results here are the final cross scan. After each of the cross scans, we updated the calibration offsets, calibrated offsets. And in general, we've never seen a calibration with this low of offsets before. The azimuth is particularly low. In this, it's around 7 to 8 thousandths of a degree, and then the elevation is about 200. So actually, the azimuth is roughly around 100th of a degree, and elevation is around 200. So, and then the most critical thing is the 2D error, which is a combination of the as and the L of the error. And in this case, it's more dominated by the elevation, and it's about 2/10 200ths. And if at 200ths error, the difference in power from being 200ths off versus dead on is really pretty low. You can see kind of that in these curves here. I just note on the curves the fits were, that's about as good as fit as you can hope for. That's a fit between the power measurements and the angle off bore sight effectively. And even at the, down when you're well off of the bore sight, the power measurements were hanging in there. It just looks like it's definitely Gaussian shaped. really encouraged by this. You can go on the next slide here. So I've just kind of put a summary of the 3 scans here. First thing to note is our results scan to scan are very consistent. We used to see with the current system a fair the variation would be easily with 1/10 of a degree or so, and here it's well into the low hundredths of a degree. So in general, comparing with the old new system, these are again just my intuitive estimates. The rectangular scan centroiding the current system with 12-bit encoders was like 0.1 to 0.15 or so. This cross scan with the Gaussian fit and 16-bit encoders is it's in the range of 100 to 500ths. And I think the added accuracy, comes from both the encoders and from the Gaussian fit algorithm. So, because we had seen with the 12-bit encoders and the Gaussian fit, we saw a significant increase in accuracy with it, but it wasn't this low. With the 3 scans we ran, the overall errors in general got smaller. And so I think the results indicate we have a good chance of meeting or exceeding 500ths of a degree pointing and tracking. And with the new Gaussian fit and 16-bit encoders, I think our limiting is the tracking accuracy now, how well the tracking algorithm works. So I'm really encouraged by this results right now. It's just, I would say, preliminary because we don't have very many measurements, but it'll take some time to really run this over time and see, if it continues to perform this well. Next slide. You see, as we had done in the last trip report, also looked at the half-power bandwidth, particularly because we were running with a different speed, and I just wanted to see, how this compared with the 1420 feet. And so one of the parameters that comes out of the Gaussian fit is this standard deviation. And from that, you can compute the half-power bandwidth with this standardized equation. And what we see is that the numbers are pretty close to the expected value of 0.87 degrees for an 18-meter dish at 1296 megahertz that has a efficiency, antenna efficiency of about 0.65, which I assume that's kind of the range we're in. But and I got those numbers from this website that I've shown here. What we see really is that for the azimuth, the values are real consistent at about 0.85. And then the elevation are a little more spread in them, but their average is around 0.9. So, but they're pretty consistent. So it looks like the beam width in azimuth is slightly narrower than the beam width in elevation. I don't have any explanation for that. But it does seem to be and it's only a slight difference, but there seems to be a bit of a pattern there. Go on the next slide. Let me see I also did the main lobe beam pattern, the standard type of diagram. And basically took the absolute angles that we had and they computed them relative to the foresight, so we can get relative to foresight type angles. And I used the peak power for pointing directly at the object as the 0 dB reference point and computed all the dB values relative to that. And then I plotted the results. And one thing I'll note from difference from our previous is these values they really hold to the Gaussian curve below 20 dB, which what I was seeing on the 1420 feed, they started to flatten out around a little back 14 dB or whatever, which I attribute not to the feed or the antenna, but to some rate RFI that we had in the receiver. With this particular case, we didn't, the spectrum looked pretty flat, so I didn't see any RFI or anything like that. But as you can see, it adheres to the Gaussian beam pattern just almost exactly, except when the signal gets down to minus, 18 or 19 dB. So I think that's pretty good. It also, I think, indicates our antenna's probably working pretty well, I think.
Yeah, these are very nice results. A question, when I'm running system 1 and I look at the target circle, is that target circle just keeping the target within the half power beam width?
I believe that's right, Glenn. Isn't it the target circle is half power beam width?
To me, the circle represents the field of view of the antenna.
Field of view being the half power beam width?
Yeah, well, yeah, it is. You're right, it is, Lewis.
Okay.
Yeah, I think if you run at, well, you have to tell it what the frequency is, but.
Right.
And I'm not sure how you change the frequency.
There is a pull down to change the frequency.
So you need to make sure you do that. If there's not communication between the receiver and the laptop saying I'm running at this frequency. So it's kind of a manual thing, but if you do that, then you get that. And if you look in this diagram, 3 dB down is really high up in the chart there. You can't really discern exactly where 3 dB is. I meant to draw it in, but I forgot.
So if I wanted to track something real tightly,
right,
I could just pull down the menu and change the frequency, put it to a higher frequency, which would be a narrower bandwidth. And so yeah, I might try that sometime.
Yeah, actually, I think
what you're saying is not true, actually.
Yeah.
No, because really that's just a graphical display of the half beam width. It doesn't really affect the tracking of the system.
There's a tracking thresholds that are separate from that.
Oh.
So it's just a graphical representation of the frequency, essentially.
That might be a good mod, but interesting mod. And in fact, that's the next area we want to look at is we have a pretty coarse tracking threshold. And part of the reason for that is that, the way the mount is controlled, it kind of turns it on and off. And that's a little bit, that's kind of hard on the mount, we think. So we're going to try to minimize that. And if we can, then we can go to a tighter threshold. We should be able to, assuming we deal with the mount control issues, get down to, 1 or 2 hundredths of
Okay. Yeah, the reason I was asking, because I've done an experiment. I tried to track, there's 2 pulsars that they look very close together in the sky. They're both at plus 54. They're separate in distance, but they look like they're close together, and they're both within the half power beam width. They would both appear theoretically, but I've tried and I cannot capture both of them at the same time. And I don't know if it's because we're tracking one and the other one only just drifts in and out, or what.
Well, it should track the one that you specified,
Yeah,
because it doesn't do auto tracking. It doesn't take the signal and then update because, the signal's way, way too low in the case of a
yeah.
pulsar. It's just kind of blind pointing at the right ascension declination of the object. And I do think because of our tracking, I think we're using a tracking threshold of somewhere around, I forgot what it was. I think it's around a 10th, Glenn, if I'm right.
Yeah, it is. I think it's 0.11 or something like that.
So what that means is, our tracking error is going to be probably half of that value. And so even though we've probably got a calibrated pointing now that's better than that, our tracking is not better than that. And I do think that, with improved tracking, I just have a suspicion you might be able to see some at least slightly dimmer pulsars because, when our tracking error, because the tracking error introduces noise into the power measurements on the pulsar. So that's a source of noise that is going to hide the dimmer ones for sure.
What would really be nice, Dan, is, once we get the system installed, is to have you come down and then go after your calibration pulsars and see how well or how short of an exposure you need to actually, or integration time you need to actually get it.
Yeah.
So that's something that would be useful in the near term if we can figure out how to do that.
Yeah, I'm going to try to get pulsar data collection on the receiver and also hydrogen line data collection. But right now it just collects just radiometer data basically. So, and with the pulsar and radiometer, you'll be able to plug in USB drive in the front panel, run it, collect the data, and then take the drive and do whatever you want to do with it.
Yep.
And my big problem with the receiver right now is finding why I've got that RFI in 1420. So we've just been focused on this, and I'm focused on that very much. So last slide. We want to finish the 16-bit encoder installation test. So we need a permanent mounting for the Ethernet switch, and the plan is to put it in the box that holds the Pi up in the upper area of the pedestal. After we removed the old parallel interface, there's a lot of room in that box so we should be with test fit, and it should fit in there. We need to put the cable clamp on the elevation axis, and we also need to do some cable ties down below in the tower to keep the cables out of the way and keep them from moving around and such. Glenn needs to install the latest version of the Ops console software, which I don't believe is a difficult thing to do, and then run some final tests. And I think at the end of this next trip, we anticipate, unless we have problems, leaving the system running with the 16-bit encoders. So I see, and then in terms of future work here, we still would like to enhance the mount tracking. Right now, the way it's tuned, it doesn't really make effective use of the 16-bit encoder resolution. Want to reduce tracking errors, and we want to understand now the mount drive controllers work better so that we can use them more effectively and with less wear and tear on the mount. I see a note. We can switch over whenever. I think it's just that it requires a site trip to switch over. So, let me see. In terms of other things, there's some software architectural issues that Glenn and Phil will probably be working on to make separate out some tracking logic from the user interface logic. And one of the things I would kind of like to hear other people's opinion on, right now, the Mount Drive interface electronics shelf is in the trailer, and the control voltages run from like 0 to 5 volts across this cable that's probably 60, 80, or 100 feet. And one thing in particular, when we're running at the sidereal track rate, the drive voltages are like 0.2 or 0.3 volts to get the lowest rates. And so it just seems like trying to reliably send 0.3 volts across that long cable run might be subject to noise and such. So we've talked about the possibility of moving that drive electronics into the tower. One other question I have for you, Bill, is at one time I know out in the tower there were RS-232 connectors that you could connect to the drive controllers. Are they still in place, or were those removed?
Well, originally there were, are you saying the RS-232s that connected the encoders, or?
No, they connected the controllers. There was my understanding there was like a switch that you could switch that cable between 4 different connectors, and I believe when y'all are working on the System 2 stuff, y'all actually connected through that interface. But
Well, originally we had a set of switches that changed us from System 1 to System 2 on the encoder inputs, and then on the outputs of the of System 1 and System 2 to the drive computers. But actually it was mostly the encoders. They were all what are they? The 25 pin or 32 pin connector switches, and those were like RS-232 parallel connections that we just switched the encoders from one system to the other system when we were running System 2.
It wasn't really RS-232 control or signals running across there. It was just whatever.
It was just the encoder signals.
Right.
Yeah.
So
parallel encoder signals.
So Bill, the System 2, when it drove the drive electronics, was that done up in the tower, up in the pedestal?
Yes.
And how was that interface then?
I don't remember. Ray, do you remember how you did that? Ray designed this thing.
Oh, okay.
So
I
the
did what?
Yeah, System 2 control of the drive mount was done. I don't remember how that came out. It came out on I/O ports on the controller puck that was in the System 2, and it all happened in the tower.
Was it the connector for the hand paddle or something that was used?
Yes, that's
yeah,
what
that plug. The hand control plugs in the bottom of that big,
box?
where the drives are at.
Right.
It plugs in the bottom, and you had to make sure that you disconnected the one down in the trailer. In other words, the manual control. You had to disconnect that before you plug that in, or you'd have drive voltages coming from 2 different places and things, and that didn't work. But that's the only one I can remember right offhand.
That's right. Yeah, the System 2 replaced the hand controller. It basically emulated the hand controller on that port.
On the
into
underside of that box?
Yes, yes.
Okay.
Because y'all probably plugged in there. Yeah, I traced well, I mean, does this make sense? Does anybody think it's a real issue that we're running these low voltages that cause pretty long cable runs?
Well, if we have them in good cable, twisted pair cable and shielded twisted pair, they're probably okay, as long as there's not a large current load on the receiving end. So we drop the voltage. So far, we haven't really seen the noise effect. If we saw it, we'd see, the drive balance and errors in the drive control. But so far, I don't think we've seen that, have we?
Well, we've seen when it gets real low, like, and this may be, stiction or whatever, but when it gets down, when you get the signal down to about 0.2, then the drive doesn't move anymore.
Oh, okay. Yeah. Yeah, it could be
And
that we just have too much voltage drop all the way through.
I don't know if that was what's happening or not. I wanted to check the volt, just kind of measure voltages out but I'm kind of hesitant to get around those controllers because there's some high voltage around.
Yeah. Well, and if we needed to, we could do a voltage translation with some op amps and boost the voltage in the trailer and take it back down at the pedestal. And that
Right.
would eliminate any cable induced noise, kind of like Dolby.
Yeah. So that's just kind of an idea we talked about. I mean, in fact, that shelf mount drive interface electronics is driven all across USB 2. So we talked about just kind of having like a USB server type thing, which is just a small little box out in a tower and connected to internet and then, or the Ethernet, and then both the encoder interface and the drive electronics interface would both be across the Ethernet at that point, which would, be a nice capability.
Yeah, that would be.
We haven't prototyped that USB thing. We may try to get a USB server and just put it in the current configuration and see how it works and not move the hardware. So we see as far as the receiver, want to try to do some more work on the radiometer calibration to get it calibrated. And then I was thinking of loading up Virgo on the receiver and trying to get it running. It seems to be a nice capability. It's already implemented for hydrogen line work, and I know Dan has done some work. And as far as pulsar data collection, I've seen some new radio flows. I think it's more from Marcus Leach and such that that can collect pulsar data, at least, for lower bandwidths anyway.
Yeah, we're using the one that originated from Marcus Leach, and then K5SO in New Mexico, he modified it, and then we modified it. So it's a GNU radio flow. And then what I did was I converted it to Python and C. So it's just, I call it from a shell script now.
Oh,
But,
right.
yeah, I'd be glad to give you that. And then on Virgo, yeah, I've used Virgo for hydrogen, and I've also modified it for when we get the new 1420 up and try masers, I'll be using Virgo for masers also.
Oh, okay. Yeah, I was thinking of trying to put kind of a user interface on the front of Virgo so that you didn't have to start and stop scripts. You could just select parameters and hit a start button, and it'd take off and run, and just the way it runs now.
Yep, I just got used to using the scripts.
Yeah, I mean, it's kind of a standard way. So those are the things I'm looking at right now. I think that's about all I had. If you have something to add, Glenn.
Yeah, the only thing I'd like to add is just that I just wanted you guys to know kind of who worked on what just for the last year or so. Myself, I've been working on the actual software interface to the encoders, which was a kind of a bus interface over TCP/IP. And then I did all the update work to the simulators so that we can run the software here in Colorado Springs without having to go to the site to do the development and test. So that was kind of the area I worked on. So I was working on the encoder interface and the simulation of the hardware. And then Phil, and I'm not sure if Phil's on or not, but Phil did all the work with the user interface. So he made the user interface as far as being able to run these calibrations or these scans a whole lot easier than what they used to be. And he worked with Lewis to understand how to plot the data and get the correct data so we could run these scans. And then obviously Lewis worked on the receiver side and worked on the algorithm side as far as being able to do the Gaussian fit stuff. So that's kind of the work, kind of how we broke out the work. So anyway, that's what we've been doing.
Okay, anybody have any questions before we move on? Yeah, I'm sorry to forget. I keep forgetting Phil. He does a lot behind the scenes work, whereas Glenn and Lewis come on in the Zoom meetings and explains everything what's going on. But Phil has done a lot of work for us as well. Yes. And as you see, the whole reason behind this, as Dan was saying, trying to find pulsars and soon to find masers and all the other stuff, you got to have accurate tracking system, and that'll come into play here on our next presentation by Paul. He disappeared. Oh, there he is. Okay, so the next on the list, let me bring up the agenda real quick. We covered the ARISS demo. We covered that already with Roger explaining what happened and some pictures. That was on the local TV stations tonight. Although I was kind of disappointed they did not show any actual contacts being made, but they did show a general idea what was going on. So
what network was that?
Channel 13.
Okay, I set up to record all the stations, so I'll paw through them and see if anyone else covered it better.
Yeah. So, Paul, the board of directors met last Wednesday, and with Alex on board, Beret was there, and Desiree Backus, our new marketing media person, to help out Paul, and we discussed this EVA 25 and EVE 25. There you go, and the board did an email voting to approve or disapprove. The board overwhelmingly approved this project. So I'll let Paul explain what's going on. And then you can roll right into the upcoming events after that, Paul.
All right, sounds great. Thank you very much. And thanks everybody for being on board here tonight. So we're going to talk about EVE 25 or EVE 25. Let me see if I can share my screen. I know how to do that still. Here we go. So I'll just take you through this really quickly and talk about this serious project that we've got going here. So project EVE 25. So next question is, let's see if I can find that. I don't know, I gotta move this thing out of the way. Okay, there we go. Oh, come on, change. Resume slideshow. There we go. Come on. Let's go. This is weird. From the beginning, from the first.
You got to reload it.
Maybe, I don't know. Let me try this again. I hate to do this, but I'm gonna fix it here. I'm not gonna let this get me down. All right, let's try this one more time here. Okay. Slideshow from the beginning. Here we go. There's the first slide. And
Paul, you're not sharing the screen.
I know. I'm just trying to see if I can get my screen to do it.
Oh, okay. Go ahead.
And I see it now. Okay, I got it. I had the cursor on the wrong place. So what is the project? Okay, so it's Earth, Venus, Earth. It's the radio communication attempt by bouncing a signal off another planet.
Slides aren't there.
I'm not seeing anything.
All right, stand by. Let's see if this works any better. Is that any better?
Yep.
There we go.
You got the whole screen? Okay.
Yeah.
All right, good. So it's radio communication. So communications means something intelligent going one way and coming back and talking to somebody else who's hopefully intelligent too. So the Venus will be at the closest distance to our planet in March next year. So we have a target date that we have to adhere to. Otherwise, and the thing about Venus and my good friend Ray, he explained to me that you can't really shoot it when it's right closest to Earth because the sun's right behind it, and it makes a lot of noise. So we want to make sure that we get it as it's coming towards the closest distance and it's going away from the closest distance. And those are our two little windows in the March, April timeframe. So
Isn't it that you'll cook the package?
Well, that too, but
Okay.
but we just don't look at the sun, right? It's the same for eclipses, it's the same for anything else. You gotta don't look at the sun. So anyway, so what's the thing about Venus? Well, it's about the same size as Earth. Okay, that's kind of cool. Although if you had to work a day in Venus, it would be a really long day. It'd be like 243 Earth days, so you'd be tired. Temperature's a little warm, 900 degrees Fahrenheit, so it's definitely a hot beach. And when it's closest to us, it's about 24 million miles, which is, by astronomical stuff or astronomy stuff, is pretty close. It's very, very close. And just so everyone knows, Venus is named after the Roman goddess for love and beauty, and also known as Aphrodite by the ancient Greeks. And there was a secret project actually that nobody's actually admitted to, but we actually landed one of the people from Earth on Venus. And I know it's not in the news, it's hush hush and everything else, but they actually landed a guy on there. And with that hot day and everything, it really does affect somebody. So here's what he looks like now. So that's our Venus operator that's going to be listening for us. That's courtesy of our DSES member Jake, KG7GQB. So anyway, like I say, we're very serious about this project. So the goals for the project is we want to get some excitement and awareness around our society and promote our mission. I mean, we want to build some interest in membership. So we want to get everybody on board and as many people as we can to participate in these science experiments. So we think there's a lot of pieces, a lot of moving parts to this project. And if you're interested at all, please let us know for sure. Send a message to the board at dses.science, and we will definitely use your help. We need people just about in every aspect. We have a director of media and what was the other part of that? Anyway, she would love to have some help if you guys are interested in PR or any of that kind of stuff. Anybody's got those kind of skills, we'd love to have you. We have lots of different groups that even outside of this project that could use people. So if you're interested at all, please submit your name, and if you have some friends, please invite them as well. We could use all the help we can. Also, by the way, one of the other things too is we want to try to, using this project's awareness, is trying to solicit some additional donations to our society so that we can keep the lights on, keep the new building heated and cooled, and all the other nice things that we do. So the objectives are really to send and receive some digital signals. In this case, Q65 is the algorithm that we're using from WSJTX, and it'll and that will allow us to gather a lot of information, a lot of the signal over a period of time, so that we can make sure that we will be able to contact it. And we also want to have someone else in the equation as well. So another station, there's a group in Germany that did a single ping or so we say a very limited reflection off of it back in 2009, and they're very excited about this project, and maybe they can be our go-to station for a QSO. So that's kind of what we're looking for. We think this project can be great in terms of helping us extend our teaching skills into the STEM classes in Southeast Colorado. There's a lot of high schools in Southeast Colorado that don't have a lot of the access to things like we have in the big cities. So we want to be able to reach out to these folks and show them, I think this will really catch their imagination. We also want to work with universities like CU and the other colleges and tie into some astronomy groups that exist right now in the U.S. and who have some similar capabilities like we do at Haswell. Hopefully, maybe Skip could put up a big antenna, or maybe you already got a big antenna, Skip. You might be able to hear it. You never know. Anyway, let's move on here. Okay, so this is the history we talked about earlier. The NASA did this back in the 1960s. It actually had a big transmitter, about 10 to 13 kilowatts, into a dish antenna, and they were able to do the bounce and got a lot of good information about that, especially its reflectivity, which is really high. The AMSAT Germany team from the Bochum Observatory also, these are the folks I just mentioned, in 2009 did a echo test off the surface of Venus, and they were able to, it was the very first time for Germany and Europe to do anything like this. So it's about the farthest distance crossed by amateurs. So funding, we're going to be going out to the ARDC, ask for some funding to make this work. The figure is going to cost about $50K. Here's the project plan, we figured out through Alex, K6VHF is our resident NASA engineer, and he's able to determine the path loss between Earth and Venus and back is about 346 dB, which is a lot of path loss, and it's going to require a lot of things. The folks in 2009, they were using 6,000 watts into a 60-foot dish similar to ours, and we're going to try to do this with power of 1,500 watts, a lot less, and keep them within the ham band power limits using our 18.2 meter dish. So it's almost the same size as the one in Bochum. Anyway, so a lot of interesting things here. There's going to be a Doppler shift. We figured it's about 5 kcs, which is not very bad, and your delay in getting the signal back is up to 5 minutes, depending upon how far away you are. So it's not too far, but it allows us to be able to send a lot of information and capture a lot of information over the 5 minutes to decode the signals. And here's some calculations that we did to see if we could make the jump. This is the frequencies. The bandwidth is going to be about 100 hertz or 2.5 kcs. Signal to noise is going to be our digital mode, or Q65, and with that, Q65 can go down about 30 dB into the noise, or 30 some odd dB into the noise over a certain period of time. So we're hopefully being able to use that capability to decode these signals. And the receiver noise figure, we've got to look at how we can get this down a lot farther than 1 dB. Anyway, you can kind of see the numbers that we used here. We get about 63 dB with the 1,500 watts. And these are some more calculations that Alex had done. And if we can get ourselves a really good LNA, we could probably get down to minus 2.9 dB for a signal. So if that was a if that was a regular signal, you wouldn't have any contact possible. But because we're using digital communications, we can go down actually much further into the noise beyond 0.2 dB. So that tells us that this is a possible. In other words, we have a good shot at making this work. And next steps, we're going to have a project plan, timelines, cost benefit, and all that kind of thing. Right now, Alex is working on a preliminary design for the system. And we're also going to be working on a funding proposal. So anybody who wants to help out with this project or wants to get involved, let us know. Any questions so far? Guess it must have been pretty clear. All right, let's see. What's next? I'm going to, if there's no questions, I'm going to move on to the next item, which is the Dubis contest coming up in May, which is not very. Yes, you have a question?
Oh, just a quick comment with respect to the System 1 software and pointing the dish.
Yes.
This new version that we're installing has the capability to track Venus. So basically all you gotta do is say select Venus and then the map will go there. The only thing that I'm slightly concerned about is our sun exclusion logic.
Yes.
It basically will tell you that you're approaching the sun, but it will not keep you from going into the sun.
Oh.
So when we designed the system originally, I think at the time, I think everybody involved said, well, we don't want to cancel it, but we want to know that we're getting near the sun. So there is an exclusion area around the sun and it will tell you, but you need to be aware that you probably should stop or try to figure out the best way to get around the sun. That's just some thoughts anyway to think about.
Well, one possibility is we're going to paint the dish.
Well, I guess that'll help.
Yeah, a flat white infrared absorb. It'll add weight to the dish, which may affect tracking at low elevation. We'll be at real low elevation, so the paint will add weight to the dish, but paint will solve part of the sun pointing problem.
So basically the software will tell you you're getting close to the sun, but it won't keep you from going there.
Yeah. Well, we just have some alarm bells that go off in the control room when that happens. We get close enough that it should, well, you know, we should have something that really lets us know, some audible thing.
Actually, there may be audible built into it. So
we actually had that happen in one of the EME events, where the tracking sensed that we were coming into the sun, it shut the dish down, and we continued to drift towards the sun. And I got real concerned at that point, but we missed it. But still,
you mean the sun started drifting towards the dish?
Well, yeah, the Earth was rotating us into the sun, even though the dish had stopped. But the dish did detect that we were in that exclusion area and started tracking right into it, and it stopped. But then the rotation of the Earth put us back into, a collision course with the sun. So, yeah, if we have any way to keep us out of the sun entirely, that would be nice. But I don't know, painting the dish, that's a big project all by itself.
Well, that'll have to be part of the project, maybe. We can figure out how many gallons of paint, a sprayer, one of those cherry pickers to spray it in there, and see.
Well, this is aircraft grade aluminum.
Yes,
and doesn't paint well.
No, they paint planes, so they gotta have something.
What is the objective with the paint?
The idea with the paint is it doesn't reflect IR. Right now, the dish is just raw aluminum, and it reflects all the IR energy right to the feed point. If you track into the sun, it will melt the feed point.
Oh, okay.
And we've actually done that too.
Oh my.
So what the white paint does, if you look at all the professional telescopes around the world, most of them have a white surface coating that's non-IR reflective, and so they don't put the infrared energy onto the feed. We didn't have that in this dish because this dish was never intended for sky pointing in the first place. It was mostly for horizon, pointing to the north.
Ah, okay.
Just one other quick comment, I'll let you go. But there are pull downs on the System 1 software that will bring up a little displays to show you where the sun's currently at, where Venus is currently at, and where the mound is currently at, and you can get a feel for where you're at via these tabular displays versus looking at the GUI. But you can get the as-el position or right stitch and declination position for all those things by bringing up these little tabular displays.
Well, that sounds good, Glenn, and we've got some time.
Definitely got time
to work out those details before we get there. Let me
It might also be interesting just to put a thermometer up there. And when things start getting warm, that's where you can have your bells.
in the dish. I got it. Let's see if I can unshare here. Stop the share. Okay. And yeah, that's going to be, like I say, an all society project where everyone gets involved, and we need to ask some experts on aircraft paint, how to make it stick to aluminum. So so Bill can have his sprayer. We'll have a good sprayer up there. Anyway, it would look really cool if it was white. I mean, it would just look so neat, I think. But that's just me, It's marketing.
Yeah.
Let's talk.
Paul, can I make a comment real quick?
Oh, absolutely, Ray. Go ahead.
Yeah, I haven't worked out the math on it yet, but ideally we would like to be leading Venus by a couple of minutes or so. When we actually do our EVE, we have to point where Venus is going to be in a couple of minutes when the signal hits Venus and then starts bouncing back. So we might have to get the tracking guys to help us with that.
Yeah, I'm trying to get a hold of Joe Taylor because he has this tracking software in WSJT for the moon, and it would require a change somewhere along the way so it could figure out what frequency do we have to transmit in the first minute, and then the second minute, and then the third minute, so that it all comes back in the fifth minute.
Yeah, it's a Doppler shift thing, but we still have to point our dish where Venus is going to be when the radio signal gets there, because it's going to take a couple of minutes before it arrives at Venus.
This is true.
So we have to do a little Kentucky windage on it. And
that should be something that we could add to the software by next year, where there's some type of offset value. If you look at how the software works, it's basically sending a current time to the function that calculates the object position. And we could have maybe some type of offset that would give us a position based on a time in the future or something like that.
Yeah.
So it's the software for the object calculation, regardless of the moon or the Mars or Venus, it takes a time in, and if we can put some type of offset onto that time, we should be able to get a calculated position for it.
Good, perfect.
But we're not using a laser, so.
Yeah. That sounds like a fancier answer when I was just going to tell you, give it the wrong time.
Yeah, Venus time.
Yeah, Venus time.
That's exactly it. You're just giving it the wrong time.
Just have to talk to our guy there. All right. Let's talk about
the laser would need it too.
A laser would surely do it. Yeah, I don't know about ours. We're going to be pretty wide anyway, so I mean, by the time
same speed,
right?
Same speed.
It's all the same speed. That's true. All right, let's see what we're doing here. Okay, let's start off with. Let's see. Go to my share again. I can find share. Where is she? There she is. Share screen. Okay. And this is the guy here. Okay, so next thing coming up in a couple of weeks. Actually, it's what 2.5, 3 weeks, something like that. It's May the 10th. We got the European Dubis International EME contest, and last year we took second place. So we have a good shot at this thing if we put our minds together. And it's sponsored by the Dubis and REF magazines and organizations. Neat thing about it is it's not digital, it's CW and it's sideband only. It's like a throwback contest like we did back in the 1980s before we had the internet, all that kind of stuff. It's like a real contest, but this time we're bouncing off the moon. We're going to try to get worldwide activity according to their publication. And the different prefixes form a multiplier. The 1296 is a special one because it's the VK3UM Memorial EME contest. So it's VK3UM is a pretty prominent person in the EME world, and it promotes random EME contacts, which is something that a lot of people don't do. Most guys have this thing set up on what frequency, what time, and et cetera, et cetera. Well, this time we're going to try to have as many remote. In other words, you just can't call a guy up and say, let's meet. You can have SCEDs, but you don't have, you can't do real time scheduling, and you can't use packet cluster or anything like that during your moon window. Now, outside the moon window, you can talk and say, okay, listen for us around 1296.070 and that kind of stuff. So the category, we're going to be in the QRO, which is the high power category, multi-op, which is going to have more than one operator. And for a valid QSO, we've got to have all the following information: just the signal report and the call sign and the Roger. They don't have to capture any other information. We don't have to have their grid spare or any of that kind of stuff. It's pretty straightforward, which makes it easy. So multipliers, you get 100 points for each contact completed on 1296. You get 10 points for each QSO SCED. So if you set up a SCED ahead of time, you can get 10 extra points for that. Whoops, here we go. Multipliers. Every prefix is a multiplier, which is kind of cool. And so you can get a lot of these different stations. So it encourages us to work the JAs and the guys in Australia as well as the folks in Europe. So what time do we have to get up? Well, moonrise on the 10th, which is the day of the start of it. It actually starts at 6 o'clock our time, but the moon comes up on Friday morning at 5:25 and goes to sleep at 11:34. So usually between, well, we won't be able to work a lot of Europeans because the Europeans will be all in bed by that time, or they won't see the moon anyway at 11:34 p.m. So our only contacts are going to be probably the first little while is going to be US and maybe JAs or something. The second day, which is the Saturday morning, the moon comes up at 8:22. And we have all day to do that, but the Europeans usually go away around noon to 1 o'clock because they lose the moon at that point, and then we can start working South America, U.S., and anything to the west. And on the Sunday, if we choose to operate that day as well, the moon comes up a little later at 9:25, and it lasts right through the next day. So there's also a special contest. We have been asked by the Germans because of our station and our reputation and how we did last year, if we would be in the what they call the appetizer contest, which I've never heard of before, but this is the first time for it, and it starts the day before Dubis. So that starts on the Friday morning at 8:25 is when we get our moon. But it actually started the evening before in Europe, and it only goes till noon. So it's a very short window there for us, about 4.5 hours. But we can work a lot of Europeans, I think, during that period of time on single sideband only. So and Andreas DJ3JJ sent me a spreadsheet log to use. So it's just something for some fun if we can get the package into the feed the weekend before and test it all up, then it'll be ready for us on Friday morning. But that'd be fun. Anyway, so that's the story. And if you want to operate, please let us know. and when you wanna do it and what you prefer, CW or sideband. So we're open to all comers at this point, and we're gonna look for operators to fill up the time schedule between Friday morning and Sunday. Any questions on any of this? Ray, do you think that we can get the feed up on the weekend before?
Let's see, we've got the feed up there right now, don't we? And so
Well,
not a case of feed, but the Alec or the Diane package will have to get up there.
That's what I'm thinking about, the Diane
Yeah.
package. We got to get that up there. I don't know if Alex is still on board here. You still there? I think I see you in the picture there. Alex, hello. There you go.
Yes, I'm here.
Yeah, so the weekend before, let me stop sharing here. Okay, so the weekend before is that would see that would be like the May the 4th or that week or some anytime next week or during the week of, but I would like to try to get it tested and settled by the 5th. I think if we can do it by then, at least we know we don't have any technical issues, that everything works as engineered. What do you think, Alex? Or I know you're waiting for some parts from Europe.
Yeah, I don't think they will arrive on time. So no, they're being from Eastern Europe ship, so it's been a problem recently. So what I'm going to do is just put my board there. I have to slightly modify for Diane, and then field test here and ship it to you or to Ray. Just let me know who needs to get that. I'm gonna leave.
Send it to Ray for sure. I can't do much with it here.
Okay, but the earliest I can ship would be May 1st.
Oh, okay, that's good.
Yes.
Yeah, that's still within the window. Yeah, because we can get it installed up there and make sure the birds don't make a nest anymore. Then I think we can at least test it out and see how it operates.
Yeah, I replaced a couple of fans. Fans were bad. And then I clean up, so I have to pull all guts out and clean up. So I apply some modifications for the future use. So I think, and everything works fine. I'm just, it can be shipped today, but I'm just leaving tomorrow, and I'm not going to be able to ship it tomorrow. So
understand? No, not a problem.
Yeah.
Yeah, that would be great when you get back from your trip. That would be super. We can get that tested and do any troubleshooting ahead of time before the day of.
Okay, thanks,
Because
Paul.
someone mentioned, go ahead.
Yeah, I was gonna say, what'd you have, Roger?
Because someone mentioned bird's nest. Does anyone know how well that the bird spikes that I put on the on Diane that time, how well they worked?
They actually worked reasonably well, I think, but there's one place we must have missed because they got through. A big one did.
Yeah, lots of poop.
Yeah.
Paul, yeah, there was a lot of material in there that kind of mucked up the fans and the equipment. Paul, I was a little confused by the appetizer on Friday versus the regular contest. Could you publish that chart of the schedule for this full contest, including the appetizer?
I'll send you the whole file. But I can put it anywhere you want. Where should I put it? Or who do I send it to? Maybe I send it to Myron, and Myron, you can send it.
Or you could just put it in the chat if you want to.
Yeah.
I was a little confused by it, but maybe we want to put it on the site so people can plan around it.
Yeah, it'd be probably a better place for it, and I can send it out to everybody, or put it on the IO page, and I'll get it and send it out. So
I think that'd be great. And that way everyone gets the information there's no problem. I'll just save it as a PDF and I'll send it over to you, Myron. How's that?
Okay, that'll work.
Perfect.
All right, we're 2 hours into our hour and a half meeting, so next on the list was Bill. You want to continue on, Bill, or do you have much to say? Because it's been a while since we've done much down there as far as the building goes, but what do you want to do?
Well, it has been a while. Quickly, I'll tell you what I'm working on, and I'll share this. Right now, I've asked Kyle to bring a skip loader down and cover the power line splice trench that's right under the small dish. That's still an open trench, and he called me this week and he said that the guy that was going to do our sheetrock in the kitchen and the bathroom has moved, and he's looking for a new person to do our sheetrock. So there's that. And while we were talking about it, I said, we got to cover that power line trench because it's still open. And if it floods, we got open wire, even though it's spliced and protected. I don't trust it in the trench. So we got to do that. I asked him to do batting insulation in the kitchen and bath before doing the sheetrock. If he can find a sheetrock guy. Today I started calling spray foam vendors again. It's been quite a while since we did a spray foam estimate. Previously, I was unable to find anybody that would paint their spray foam. Today, I found one in Pueblo that will do that. So he's going to give me a quote, and if that's reasonable, we'll have him go down and put the spray foam in the entire building and paint the ceiling white. Then we need to move the bathroom sink pipe fittings, get the bathroom sink moved out of the way of the toilet so we have more of a American Disabilities Act access into the bathroom. Blow out the dirt from all the ceilings and walls, install the spray foam, and mask and paint the inner roof spray foam white. So that's the main thing I'm working on right now. And after we get that, then while we're doing that, we can also do the contactor and the timers for the water heater and the pump, wiring the pump, the water heater, and the surge suppressor, and fill the cistern with water. So the things there in yellow are the things that I'm currently working on. And all this other stuff is stuff we can do after we get those things done. But one of the things I noticed, I was talking about buying the cheap cabinets from Lowe's or Home Depot. I rented this motorhome to go down to the Texas Eclipse. It had cheap cabinets in it that were cellulose based with a thin vinyl coating. And what I learned was you don't want those cabinets. If they get wet or if they get damaged in any way, they just deteriorate. So I'm going to go back and look at these cabinets from the standard off-the-shelf cabinets from Home Depot and Lowe's and see what they're made out of. So that's about all I have. You can look at the rest of this at your leisure.
All right, Bill, sounds good. Thanks a lot. Yeah, we been taking a break there from a lot of activities. Bill was out of town for 10 days. He thoroughly needed the break, and glad he's able to get away for a while. But
yeah, that was nice.
Yeah, and we'll start again now. The weather's getting warmer. Of course, we're in the middle of fire season, thunderstorms, hail. So we're giving up the cold weather for all this other neat stuff that comes in Colorado. So anyway, anybody else have anything before we adjourn for the night? I hate to carry this on too much, but financial and membership, we're 96 members. The most we've ever had at DSES, and our finances still to be good. The EME 25 project, Paul had a number in there as far as what it's going to take as far as money. And right now that's all going to be grant, hopefully donation money, grant money, whatever. Right now that is not going to come out of any of our funds for the building project. We want to make sure the building has enough funds to complete before we spend it for other activities. So I think we can do it through the grant process and other donations. So we'll continue on that route. But the current money we have from the building fund, we want to keep it there because we still got a lot to go. And I hate to spend that money and come to find out we don't have enough money to buy toilet paper. So there you go. Or other activity or other things. So anyway, that's all I have. I think 2018.
Really quick, kind of question to Paul is how widely are we advertising or asking for participation in Dubus. Last time we pretty much opened it up to everyone. Is it supposed to be still an open house type thing or what?
Yeah, I think so, because from I think from the DSES perspective, if we have people who come in and operate, there's a high probability that they will join. And I know we had a couple of people asked us already, I think it was 3 or 4 weeks ago, to be included in the operator list. So I just got to go back and find that, or I don't know whether maybe Myron had it, but I know there was some correspondence going on about that.
One thing I suggest, and it's all up to you guys, Ray and Alex and Paul, is to make sure the system works before we start inviting everybody down there. That's installed, Ray, and it bench tested the weekend prior. Nothing more embarrassing than everybody get down there and nothing works. So of course that can happen anyway, but once we do get it working, so could be another big bird show up, not the Sesame Street style. So just a suggestion. That's up to you guys. I'm going to be out of town. I'm leaving May 4th. I'll be gone almost 3.5 weeks. So the next meeting in May, both meetings in May are going to have to be run by Bill or his designee, because I will not be in town for those 2 meetings in May, or for the moon bounce. So there you go. You guys can decide on that, and I'll be available by email and phone, text, whatever. I'll be over in Europe during that time frame.
I don't mean to be stingy about our resources, but I think at the low entry price of membership, we ought to require membership to operate the system for EME. That's just my opinion, but you guys can do what you want.
I know we got some new members. Last time some guys came and they saw it. So
well, we've had a lot of members who come down there, and members who come down and provide labor is good.
Yeah. So I think people ought to have some skin in this game to utilize the resource.
Because we have the non-voting members show up and do a lot of work down there, and I like that. So I don't know if we should restrict it. I don't think we should. I think it should be open to everybody, just to give them a taste of what's going on. Since we don't do this very often.
Yeah,
that's true. Yeah.
It's like a mini open house, if you know what I mean.
Yeah. And when we get into
the DX.
Yeah, when we get in the bigger building, we'll have more room for people anyway. So it does get crowded in the trailer.
Yep.
You think?
I know it's hard to stay down there too. It gets cold in May still at night.
Yeah.
Unless Bill can get that heat heating system in there before the Dubus contest.
And this is the guy who goes to Eads and spends the night in a hotel saying that.
Well, I know. I mean, somebody's got to do it. I mean, you talk about skin in the game. Hotel rooms, food, travel, gas. I mean, that's a lot of skin there.
I have a suggestion. I think we should start actively looking for a frog that we can use as a sun detector. We put it at the feed, and as the frog, the frog would let us know, kind of like a canary in the coal mine.
But that only works if it heats up quickly, right? We all know about the frog in the cold water.
Yeah, that's
it will.
Well, frogs make good food anyway.
Okay, basically, I'll start spreading the word with the caveat that we still have to test the system to make sure that it looks like we're good to go.
Yeah, well, if it doesn't work, we'll just send out a note for everybody saying, "Stay home." Don't fly.
Paul, would you like me to have people email you if they're interested in coming down, so you can start, maintaining a list?
I don't mind doing that. If I get a list of operators and their call signs and their contact information, then I can start putting together a list of times and availability. Some guys only want to come down for one day, or some guys may just want to spend the whole time there. But
I think Saturday morning when the Europeans are available, will probably be the most interest.
Sure.
And that'll give you an idea how many donuts to buy.
Exactly. I gotta import those. I gotta get guys coming down on Saturday morning to buy the donuts and bring them down because there's
There you
no donuts in Eads.
Well, I'm gonna check out of here. We've had 28 at the max and a few people had to leave. But I want to thank everybody for showing up and showing interest, and thanks, Paul, for talking about the EVE 25. There's gonna be a lot of work to get done on this. We have a grant writing committee established. Rick Hamley's heading that up with Dan and Floyd, and Don, feel free to jump in. And then we have Alex doing the hardware, and Ray for this, but it's going to take a lot of money, a lot of time, and if we don't make it next March, we'll have it available for the following year, and we'll also be able to test that package out at various CME contests, and I'm sure our signal will be much stronger with a kilowatt into that feed. So there you go. Thanks again, and you guys can stay around and talk. I got to get out of here. So good evening, everyone.
Thank you, Myron.